Good morning, good afternoon, good evening to all the participants joining for this online seminar. Welcome to the third series of online seminar from Endress Hauser. Today's topic is temperature measurement. And let me see if my speaker is there with me and he has shared his screen. Yes, you can see it on the screen as well. Yeah, excellent. So today's topic of discussion is temperature measurement. We sometimes underestimate the importance of temperature measurement, but it is the key measurement in case of a refinery. You need high reliability, you need high availability, and you want a sensor which lasts long enough. Yeah. This online seminars are sponsored by Endress Hauser. So Stefano, can you come to slide 2? We have done on the right hand side top corner, you see a picture of the headquarter of Endress Hauser. We are a 14,000 employee company, a strong equity ratio of 70+%, which you can see. We have over 8,000 patents, and these patents are done to ensure that we create value for our customers, and we are also able to deliver innovative solutions to challenging measurement applications. In fact, my speaker, whom you see next to me, he is a patent holder on some topics which you will hear today as well. So it comes directly from the horse's mouth, how we say it. And he's a very innovative guy, very knowledgeable as well. Before we start with the webinar, I would like to go through some of the housekeeping topics. The handout of today's presentation is available in the handout section of the GoToWebinar. A small safety moment because we are in oil and gas seminar. Just to give you a hint that we are not doing physical seminar, so virtual seminar, and this is because of the pandemic situation. Just keep your distance. Social distancing is important. Make sure that you get vaccinated if it's possible for your based on your criteria in your country. Use the tracking app because it will ensure that new mutants don't enter into your country, and make sure that you do everything to keep yourself and your family safe, and we try to get back to the normalcy as soon as possible. So here you see with me my colleague Stefano Mella. He's a very good friend of mine as well. He's very knowledgeable on the topic of material science, which you will probably recognize within half an hour as well. But you can spend days together just talking about materials. Over to you, Stefano.
Thank you very much, Janish, for your very nice introduction. Good morning and good afternoon, everyone. So my name is Stefano Mella. I'm now located in Italy, and I'm pleased to entertain you for about 30-40 minutes with my presentation, and then we will have a session of 5 to 10 minutes for questions and answer. I will now shut down my camera just to avoid to have problems in the connection. So you will continue hearing my voice but not see my face. Maybe we see later in the questions and answer session. Good. So let's start with my presentation. Today we will go through three main parts. So I have the first block, probably the most important one in terms of timekeeping, and then I have two minor topics or blocks where I will show you some typical installations and a few words about LNG applications. As Janish was already introducing before, we need to have very reliable thermometers or temperature detection in oil and gas application. This is very important for safety reasons. And that's why the first block of my presentation is about heavy duty applications, and very important how to improve temperature profiling performances in your plant. So what you can see here, it's a typical, is a representation of a typical refinery scheme. Nothing new for sure for all of us. And among this list of typical application, of course, there are some applications which we see more critical, and this not mean more important, but more critical in terms of conditions, mainly temperature and pressure and types of fluids, and some others that are less critical when it comes to measure the temperature inside. And I then want to tell you where Endress Hauser has a lot of experience when it comes to measure the temperature in critical applications. Some of them are for sure related to crude distillation unit. Here I have to contradict myself a bit, not because of temperature and pressure, but because of the importance of this application, because this is at the beginning of any other transformation process you might have later. Therefore, to have a proper distillation, so separation of gases and fluids and liquids, it's very important. And to do so, to know the temperature is crucial. And then we go into another block where we have real transformation of process fluids, where we have, for example, fluid catalytic cracking reactors, or we have either treating units or hydrocracking units. And then there is another area, for example, it's continuous catalytic reforming units, where again temperature plays a crucial role when it comes to define the quality of the products which come out. But I was already saying before, why are they so important and so critical? Okay, what you can see on my screen here in yellow are some important notes, and they exactly refer to the reasons why we define them as critical. So in the cyclone reactors, of course, we have cyclonic forces, and therefore we have movement of parts inside that put our sensors under challenging conditions. When we also think about how we reach the different points, we also face with other challenges like difficult paths. So it's not easy to move inside this kind of reactors and reach the right measuring point without interfering with the already existing structures inside the vessel. If we look at fixed bed reactors, we have different challenges. Here the pressure is very high. I will tell you, or maybe I can also say it now, it's around 200 bar as an average. So I would say really high pressures. And this is also in combination with a high temperature. So you know that metals in general do not like when there is high pressure and high temperature together, and maybe it's even in combination with dangerous fluids like H2S, where H2 can then be separated by sulfur, and I will explain later, introduce some criticalities to metal conditions. And another application I was referring to before, it's a continuous catalytic reforming units, where also here, as you can see from my sketch, we have difficult paths to reach the area where we need to measure the temperature. And what are the consequences of all these challenges? For sure that some temperature sensors, most of the cases here we are talking about thermocouples, might drift because the conditions where they are measuring at are very, very critical. Sometimes, or most of the cases, they drift downwards, so they measure some degrees Celsius less. It happened also that they showed some degrees Celsius in a positive way, plus, but as a general rule, what I can say that is that thermocouples are not let's say, affected from drift or deviation for all their life. And we have to keep it into consideration. And I also want to explain why they do so and how we solved it. So let's start from some basics. So most of you know exactly how typically temperatures are measured inside a vessel. In this example, we have a three-dimensional way of measuring the temperature, okay? And we have many thermocouples all around this area. And each thermocouple is quite a simple sensor. It's done by an outer sheath, a metal outer sheath. Inside we have this powder, which is in a compact condition, compacted condition. And then we have two wires, or sometimes four, which are the electrodes of the thermocouples joined in one position. And this position is where the thermocouple is measuring the temperature. Here are some examples again about also data from the field, where we see exactly what happens when a thermocouple drifts. So you can see some temperature values along many weeks, months, or even more. And if you look at this red line, you can see that almost from one day to the other, there was a drop of about, I would say, 10 degrees. And that's really something strange, because all the other thermocouples did not show the same behavior. And this is for us a typical information or sign that something might happen. And what I want to show you is what can happen. So if we take again a typical thermocouple with the external sheath here, the mineral insulated powder inside here, and two electrodes here, and simulate a crack, we can easily show what is happening. So for sure, the internal part of the thermocouple, the white area, gets polluted with this blue color. Can be any hydrocarbon fluid. And then from the external part, this pollution, of course, will also reach the internal wires, the conductors, or the electrodes. It's a matter of time. Normally, it's due to some physical information, like how big is the crack, how compact is the powder, and how much is the pressure inside the vessel. But it's just a matter of time. Can be a couple of days, can be a couple of months. But the pollution will reach the internal wires of the thermocouple, and then from the internal wires, this pollution will spread again around. And when it happens, if you now look at what I will make appear, is this yellow flash. And this yellow flash is everything not positive. Normally is a short circuit in a thermocouple. And that's extremely dangerous because you don't know where it happens. It can happen at the tip at the thermocouple, and I have to say in this case you are very lucky, or in most of the cases it will happen along the thermocouple, maybe at the beginning, maybe in the middle, maybe close to the end. And when this hot circuit will take over the initial hot junction of the thermocouple, that I remember you is supposed to be at the end, then what basically happens is that the thermocouple starts again to measure quite well, but unfortunately in a completely different location. And there are no ways to recognize it from the control room, I can tell you. And we have deeply investigated what are the reasons behind this kind of phenomenon. And here I want to show what we have done. So we asked back from one refinery after many years of service, one used the thermocouple. And we have cut this thermocouple right in the middle, where we thought there was a failure or a crack. And thanks to a electron microscope scanning, we could see something strange. So if you look at this area, you see that it's not uniform in a way that we have black and white, but we have also a gray zone. And this gray zone was exactly the region that has been investigated by us. So the gray zone is here now in a bigger picture, is all around the two wires. I can show it better. It's like an infinity 8. And if we look at the chemical composition of this area, which is area number 2, we find something very interesting. So of course we see a lot of oxygen, but that's obvious because the powder inside the thermocouple is a magnesium oxide. So that's clear. Also, magnesium is clear to have, no problem at all. Then we have a negligible quantity of aluminium and silicium, I think in English. And again, we have something which is not at all, let's say, foreseeable, which is the content of sulfur, very high. Then we have a low quantity of chromium, ferrum, or iron, and then a lot of nickel. Okay, basically, as I said, here we should have only magnesium and oxygen, but we have also nickel and sulfur. What does that mean? That we have Ni3S2, which is nickel sulfide. So thanks to the sulfur coming from the process, and thanks to the nickel, which was part of the metal wires and the metal outer sheath of the thermocouple, this nickel sulfide was created inside the thermocouple, and is highly conductive, unfortunately. So the problem I was showing you before, it's exactly happened in this case. This short circuit took over completely the initial hot junction in a way that the customer was measuring in another location without knowing it. And here are some pictures with the colors where we see the percentage in weight of these other elements. In this case, we have the sulfur. So the more yellow it is, the more sulfur content in percentage we have. And you can see we have a lot of sulfur around the minus and plus wire of the thermocouple, very strange. And also near to the metal part, also very strange. And then some sulfur, which is inside the magnesium oxide powder. And the same, more or less, happened to nickel. Of course, we have a lot of nickel in the wires of the thermocouples and on the metal sheath of the thermocouple, but we also have a lot of nickel around the thermocouple wires. So basically, the idea we had was okay. We need. Let's start from the goal. Even before then, the idea. The goal was to avoid the deformation of such sulfides might happen again, or if it happens, that the thermocouple wires can feel it. So the idea then was to protect each inner thermocouple that you can see here where my cursor is protected. Is protected by its own metal sheath. In this case, we see 1, 2, 3, and there is a fourth thermocouple, and each of them has, of course, its own hot junction. In this case, you can see clearly in this cut section, and very important, powder and metal closure, metal tip at the end. Now, if we run the same animation for this time, this new multi-point cable sensor, we might see something very interesting. So, of course, we might have a crack. Cracks happen. It's a matter of, for example, hydrogen causing metal structures problems. So they become very fragile and then they crack, for example. So we have to take them into consideration. It's utopic to think it did not happen. And then if we have again the pollution of the powder, and this pollution will spread all inside the area of the thermocouple, and then reach the inner wires, of course, because now of the inner protections, which are 1, 2, and 3, nothing will happen to the inner sensors. And this is the very innovative thinking. We have increased the number of metal barriers from 1 to 2 in a way that any pollution of the powder cannot contaminate and affect the temperature measurement. This goes, of course, in direction of sensor reliability and also in direction of safety of the plant. Now, if we look at typical installations, so how can we use this very innovative way of measuring the temperature in your critical applications we were talking before? Okay, if we refer to the 3 examples I've mentioned before about fixed bed reactors or fractionating columns or continuous catalytic reforming reactors, we can use some of their characteristics to perform a proper installation. For example, for distillation towers, because of their architecture, we can insert our sensors and route them against the packing material which is already inside. So there is no need of difficult frames and supporting bars to fix them. And of course, we can reach any, let's say, layout and shape is desired according to normally the customer specification. If we refer to continuous catalytic reforming, then we have something different, because here we have to go inside the reactor and go into the regeneration zone, which is inside. And here we need some fixing clips. In other words, there are some small metal stripes which got fixed or welded to the internals and keep in position our thermocouples better when we use the profile sensors of the new innovative thermocouple sensor. And when we refer to the fixed bed reactors, here we can also provide very interesting solutions. We can enter from the top, like in this picture, or we can enter from the side. And normally, by means of supporting rods, which are hanging from the distributor trays, or supporting frame, which are fixed to the main beams of the reactor, like in this picture, we can keep in the right positions all the thermocouples inside the reactor, including the new profile sense reactor. Good. And now I would like to go through the last part of my presentation, which is about LNG applications. So we moved from heavy duty applications, so liquids, dangerous fluids, now to more gas applications and very huge tanks and not vessels. So this is a picture. It looks quite complicated because it shows a lot of sensors that our group, Endress Hauser, can provide. And most of them are level and temperature in this case. And I will not go through each of them, of course, but I will only focus on 2 very important ways and types of sensors we use for measuring. In one case, the temperature inside, so the cooling of the tank, thanks to skin point temperature measurement, and the other one on the outer shell of the tank to measure any leak detection. So if we concentrate on the first one here, on the skin temperature, Normally the sensors enter from the top where there are some nozzles. Later I show you some pictures, very interesting pictures about installations we've done. And the sensors are then running all along the internal wall of the tank. And then some of them, like in this case, get routed on the bottom of the tank and fixed on the bottom, on the floor. Again, by means of some clips. So they are welded to the bottom. And as you can see here, there are at the end some temperature measurements that we say are in a three-dimensional way allocated all around this area, and some others that are and stay on a vertical way close to the wall. Something similar happens also to the leak detection, where we have some vertical sensors. Normally, they provide a vertical linear temperature profile, but it's not strange also to have some three-dimensional measuring of the temperature, also on the outer shell, where we fix some skin points. So exactly on the surface of this wall to detect any decrease of temperature, which will tell to the customer, okay, be careful, there might be a leakage. Some other information here around whenever it's desired to have a local display for the visualization of the temperature is of course possible. This is a project we have handled just some months ago, where there was a greenfield, so a new tank was installed for propane storage, and the temperature range was in between -50 and +50 degrees Celsius. So not that high for sure, a bit low, but not so critical for thermocouple measurements, and of course no pressure. And what we supplied was 7 multi-points. 4 of them were installed in order to get a three-dimensional profile, and 3 of them were installed for having a linear profile. And in total, we have 12 by 4, so 48 plus other 36 points just in one tank. Of course, there are some challenges when it comes to install thermometers in these huge tanks. For example, the sensors are normally very long, and we have a lot of experience with long sensors also by ensuring the right performances, for example, to stay in class A for RTDs even when we reach these lengths. And then there was another challenge that was about the replaceability. So our customer was interested on replace the sensors, so nothing had to be welded on the flange, for instance, because they wanted to save everything, and in case of maintenance, just repair and replace the sensors. And when we deal with the so long sensors, or in this case 30 meter, so 30, very long straight thermometers, also the logistics comes as an aspect that has to be analyzed very well in order to be sure that our sensors arrive on site in a perfect condition, ready to be installed. And that's exactly the last thing we have provided: installation. So our team, as you can see in the next 2 slides, was on site, I'd say, welcoming our sensors once again after they left the production site, and checking that everything was fine, and then they started the installation. Part of installation was handled inside the huge tank here, where the skin points were fixed on the bottom here on the ground, and some others on the wall of the tank. Here you see one of our colleagues that was fixing the thermocouples close to the wall. And on the right, we have the outer part of the thermometers with all the electrical connections. And here, even if it's hidden from this by this cover, we have the thermocouples designed in a way that they are replaceable. So all in all, the customer was asking for a turnkey solution. So we provide everything, including the services, the installation, and the commissioning. Let's go through the conclusions. For sure, when we talk about heavy-duty applications and we want to improve the quality of the temperature profiling, my suggestion is to go always for thermocouples that have a double wall design, so a double wall sensor like our new ProfesSense. Why? Because as I said, in case of a crack, some fluid can enter, and you always need a second barrier to be sure that the thermocouples are measuring precisely without any drift. And we, as Endress Hauser, have the right solution. When we come to typical installations, as I said, there are almost no limitations. We can enter from the side, we can enter from the top, we can enter in an oblique way, and also in terms of fixing the thermocouples, there are no limitations at all. And when we go to the LNG applications, as I said, we can provide turnkey solutions. So we can provide supervision, services, and commissioning. And even long sensors are not anymore a challenge for us since many years, because we are used to deal with very, very long sensors, not only in terms of producing them, but also in terms of shipping and then install them. And the last point, reliable and easy solutions for long-term temperature profiling, wants to summarize all my presentation and where we as temperature guys want to be your partner. So that was from my side. I would like to thank you for your attention, and hopefully, yeah, I think time-wise it's okay. It's perfect.
Quite
We
good,
have
quite good.
some time for questions and answers, or I'm available.
Excellent.
And
Thank
now
you,
I can
Stefano.
switch on my camera again.
Yes. Stefano, excellent presentation. I think people see that you really thoroughly enjoy talking about your materials which are being used in the sensors. Just to mention, there is a reason why actually Stefano used some hand-sketched drawings for talking about catalyst converters and things like that. Because when we did the project with our customers, we had a non-disclosure agreement. And that is the reason why these are hand-sketched diagrams. We have, we highly value our non-disclosures, and we don't want to share the diagrams which we have from our customers. And I think Stefano also gets involved in, doing something very specific for a customer to meet their specific demand. And that is the reason why you don't see real pictures. Is that correct?
Yeah. It's absolutely correct. So when we are on site, normally it's forbidden to make pictures, of course, because of privacy of our customers and because most of the times we have NDAs. Therefore, I've preferred to end sketch. Sorry for the quality. I'm an engineer, not a draftsman. But yes, we are not allowed normally to share pictures directly from the site. Correct.
And Stefano, you shared the sorry to interrupt. You shared the pictures of this LNG installation. This was done during the COVID times, right? So how did you guys, did you do remote support or something like that?
Okay, that's a very good question. This was done at the beginning of the pandemic situation. In fact, as you can see here, there was no mask from our employee, so we could do the installation. But you brought up a very important point. Nowadays, we still do supervisions, but when it's not possible to go on site because of the pandemic situation, we can also provide remote support with augmented virtuality. So we have, I cannot say the brand, but some very, very fancy glasses, and we can see what our colleagues on site, or better, what the customers on site are watching from our factories and guide them during the installation activity. So this is something we have tested in the last 12 months, unfortunately because of the pandemic situation, and I have to say it works quite well. Probably it's also now part of the future to carry some installations by having the remote help of expertise from the production side, for example, or from an office, helping our customers which are directly installing the sensors on site. So very good question, Janish. Thank you for asking.
So I think you're trying to hide the name of the brand, but just to give you a hint, yeah, the guy who is installing, he wears a special kind of glasses which has a camera on it. So the camera is remotely through the cloud connected to our factory, and it also has a screen in front of the glasses. So it also gives instructions based on what is visualized through the camera, and our team supports remotely to make the right installation. So it's really 21st century. I think Stefano, what you touched is digital transformation, remote services, amazing product. It's really good.
Yeah.
Okay.
If I have some minutes, just recently we did the same for another project. It was inside a cavern, and we couldn't go there, unfortunately, but we supplied the same quality of support and service by the office, again with these glasses. So it's very interesting.
Amazing. There are some questions for you, Stefano. I think there's on slide number 13, you mentioned about new materials, slide number 30. 30. Yeah, you have mentioned something about new materials. Do we have some experience with that already?
Maybe I don't understand the slide.
No, I think you, maybe it's 29, sorry, 29. Yes. You're using new material. So do we have experience with this new material which you're using?
Absolutely. So I mentioned here two things: new materials and new sensors. So the name of the new sensor is ProfitSense, and the new materials are at the end not in terms of their chemical composition, but in the way we combine them. I was mentioning that we have a double layer. So we have an outer sheath that normally it's in the same material as the internals of the reactors are. Why? Because they provide the highest performances when it comes to corrosion. And inside, they are vice versa in the best material. And here I have to keep some secrets that ensure the highest thermocouple performances. Okay. And yes, we have experience. This product is not that new at the end, because we have carried many installations meanwhile, and there are many measuring points in service at this time. So the picture, for example, that I've put here, it's a real picture. It's impossible to understand the customer, so I could put it. And all customers which are now using since 2 or 3 years this cable are very enthusiastic and very happy. And I have to tell you, it's so innovative that some customers are now migrating from a standard thermocouple technology to this ProForSense technology, mainly for two reasons. It's more reliable, more robust, and second, it's less invasive. Because with one probe, you can have up to 6, even more measuring points.
Excellent. Now, Stefano, we have a few more questions. Let's go through them as quick as possible. What is the accuracy of Endress Hauser thermocouple sensors?
Okay, here that's again a very nice question. So it depends on the types of thermocouple. What I can tell you is as an average, we normally have some formulas which are written on our technical documents. But if we took a typical thermocouple type K in a range of 400-500 degrees Celsius, here we are talking about ±1 degrees Celsius.
Excellent.
As an average.
And the most important thing here is to ensure reliability and availability. And with all our installations, we have basically got most of those projects because we have shown reliable and available measurement for a long period of time.
Yes.
What is the maximum length of wires of these thermocouples?
Okay, at the moment we have exceeded the 100 meters. So the maximum we could do was around 110 meters. I cannot say that it's the limit. That was simply the longest we have produced. And the challenge itself, as I said before, it's not the length itself. That's just a mechanical device at the end, but it's to ensure that this thermocouple have the right accuracy, even if they are so long. That's why when we produce them, we really take care of each and every quality detail. So, for example, no moisture at all inside the mineral insulated powder, because humidity can affect the temperature. We have to dry them in the proper way when we do the hot junction and when we do the cold junction. So these kind of things, and it's, I have to say, because of our experience, are crucial when it comes to produce very long sensors.
Okay, while you answer the question, make sure that you don't click on that patch update, otherwise we'll lose you before the time. Okay, there's another very good question, and I think you will like it because you love the topic of double-walled multi-point thermocouples.
Yep.
Are there any possible disadvantages existing of such situation?
Of the double wall?
Yes, the double wall. So you talk about the double wall thermocouple multi-point.
Yes.
Are
Not
there
at
any
all.
disadvantages?
Not at all. Some time I hear people saying yes, but when you have a double wall, then the response time is slower, so it takes more time to get the temperature. This is completely wrong, because if you think about what basically a double wall sensor is, we have simply replaced the magnesium oxide powder with a metal part, and the metal part is even more reactive than powder when it comes to thermal transfer. So there are no issues at all. The advantage or the consequences are only benefits and not disadvantages.
Yeah. I'm sure there are some additional steps we take during the production, but this is to make sure that we only deliver value with this solution. Great. There's one more question, which is, I think, again, very interesting for you. I know this. What is the recommended bending radius for this flexible thermocouples in the fixed bed reactors with side entering to avoid cracking during installation phase?
Also very good question. Here I have to distinguish between the standard thermocouples and our ProForSense. So with standard thermocouple, I refer to a thermocouple like this, which I'm not saying is a bad sensor. Simply, it has to be used in the right applications. So when we talk about the standard sensors, we recommend to do not bend them in a way that the bending radius is lower than 5 times the diameter of the thermocouple. So if you have a thermocouple of 8 millimeters, the bending radius should not be less than 40 millimeters,
Yeah.
which is already very, very tight, by the way. So that's the minimum. What we do when we do the installation, as soon as it's possible, we do smoother bends anyway. And when we talk about the new profile sense, so these are the technology. Here we can even do sharper curves because here the limit is 4 times the outer diameter. So the bending radius no less than 4 times the outer diameter of the profile sensor. Why so? Because the inner sensors are very, very thin, very, very small. Inside we have a powder, and outside we have just an outer sheath. So when we bend it, we are sure that nothing gets, let's say, affected inside the probe.
Amazing. Hey, it's an amazing design. There's one question. I think this is related to slide number 13. There you are. Yes, yes. This one. This thing where you have shown nickel sulfide. How do you know that this is nickel sulfide?
Yeah. Okay. We are people for process automation, so we are not in a laboratory or a university. But for this specific case, we have asked for the support of a very famous university. I can say only here in Italy. And what we have done, we gave our probe, our sensor, to them, and they ran, as I said here, one electron microscope analysis. And of course, they could see the spectrum of the elements that are or were in this area. And they can not only see the chemical elements, but also the molecules that are inside. And they told us it was nickel sulfide. Okay. What we have done later, by knowing it, we tested again this thermocouple, and what we could find out is that this nickel sulfide is incredibly conductive. So sometimes it's even better in terms of electric conductivity, better than the original hot junction. That's why this takes over the original hot junction. And that's unfortunately what should not happen. Because maybe, yeah, because what happens at the end, it's something like this. You will see that the thermocouple drifts, and then slightly it goes again back to the normal conditions. And in most of the times, customers are saying, okay, the thermocouple again started to work. Yes and no, it's working, but it's working in the wrong position. So you are thinking you are measuring here, but maybe you are measuring here. So the process control is highly affected. I will not say
the quality, the efficiency of the process goes down.
Yeah, goes down. So if it's just 1 point, okay. But when it comes to more than 1 point, then really the process control is critical.
Yeah. I think we have come to close of the online seminar. I would just like to mention there were a lot of questions around references and around the topic of references for fluidized catalytic cracking and hydrogenation, hydrotreatment, hydrocracking, etc. Yes, we have references, but this is not the platform where we can name customers or the licensors and things like that. So we will get back to the participants who have asked these questions personally. It's just to honor our non-disclosure with our customers and with our partners that we will not name all the details right over here. Correct, Stefano?
Correct.
Good.
That's correct. Yeah.
Yeah. With this, we would like to close out our online seminar. This is Janish Kiwala signing out from my side. Stefano, any last words from your side?
Yeah, I want to thank you all for staying here with us for almost 1 hour, for the very nice questions. And I'm looking forward to maybe meet you one day in person for an installation.
Excellent. Thanks, Stefano, and stay safe, and see you again soon.
Thank you.
Bye.
Stay safe. Bye-bye.
Ciao.
Ciao, ciao.